Welcome to the STEM Pathways with Rohan Sharma podcast, where we dive into the exciting world of science, technology, engineering, and math. In each episode, we share exciting stories, groundbreaking research, and inspiring interviews with experts and enthusiasts who are pushing the boundaries of innovation. Whether you're a student, a professional, or just curious about how the world works, join us as we explore the endless possibilities of STEM. Let's get started. Today, I'll be interviewing Zach Kassner, who is studying electrical engineering at the University of Central Florida. How are you doing today?
I'm doing pretty good. What about yourself?
I'm doing good as well. I'm happy that we get to meet. So, to get started, I wanted to ask about your interest back in high school and what made you choose your major of electrical engineering.
So, honestly, for me in high school, it's just like a lot of basketball. I was skateboarding a little bit, and I got very into music. Um, and most of my like STEM interests, I mostly explored through just like AP classes that my high school offered. So I took like AP Physics 1, 2, AP Physics C. Um, I only did like the first calculus AP. I mean, ultimately, I didn't particularly know what I wanted to do originally when I was in high school. I was just kind of exploring a bunch of things that I thought were interesting. I think that's a pretty fine way for people to go about it. Like, ultimately, also in Florida, we have this program where essentially there's dual enrollment. So if you take college classes early, the state will cover all of the expenses. So if you're in like a fortunate enough spot that you can actually like, find transportation for yourself to the local colleges, you're able to take those classes. So a lot of what I was exploring too was like music classes and like English and philosophy classes essentially that I took at like my local community college, and I got to just do that for free.
So, when you got to college, did you come in as electrical engineering or do you switch it up?
I came to college as a jazz guitar major, and then I switched to physics. And then after my first year of not particularly liking the physics curriculum at my school, I switched to electrical engineering.
And so you say you did that your freshman year, you switched from music to physics to electrical engineering.
Yeah,
Um,
so during like the summer, so basically like the start of my sophomore year, I switched officially to electrical engineering.
as a freshman myself right now in college, what would you say to someone who wants to switch majors but kind of feels like they're in too deep or like don't want to waste time by having to take an extra semester or something?
Um, I don't think it particularly. I understand for financial reasons. Like if you're in a position where the college degree to you is, I just need a college degree, because a lot of people might be in a position like that where maybe they want to be a military officer and it's just checking a box. If you're in that position, I would say maybe it's okay to tough it out. But if ultimately like you want your degree to be your career path and you feel very, very strongly that there's another like career path that you could switch to, taking 5 or 6 years in college is ultimately so much less of a sacrifice than taking a full 4 year degree. Like it's not as easy to pivot from computer science into like an engineering discipline as people will make you believe. You have a much easier time pivoting earlier. And there's
So
nothing wrong with that. Like, you're 18, you're 19, you probably don't know 100% what you want to do.
yeah. So what kind of activities were you involved in during college?
Um, So I did a lot of there's like Latin dance, so it was kind of like this club where you did bachata and salsa. That was probably one of my favorite clubs. I was involved with a music fraternity called Phi Mu Alpha, so I did a lot of music stuff. I mostly like played in a band that I had, and we did a lot of gigs. So I live in like UCF is in Orlando area, and there's an okay music scene. There's bars and stuff there, so we would on like hold constant concerts and stuff like that. And a lot of it was kind of interesting because as you're breaking into that scene, it's almost like a sales position. So I would be going to like these bar owners and basically pitching, throwing these like huge events where I'm booking out all of these bands and I'm managing like all the money to basically get events going. It was a really fun experience. So like a lot of it didn't actually fall under like the traditional like extracurricular club. A lot of it was almost like genuinely just kind of created by me trying to find something that was fun and music involved.
So for well, right when you started out in electrical engineering, how long did it take you to realize that you actually did like it compared to physics or other things that you've been doing?
Um, That's actually a really good question. So I was in it for a good bit where I was kind of just toughing it out, where I was just like, I need to do something. And to me, I saw like the signal analysis in electrical engineering, and I was like, this is very familiar to me due to like having mixed music and stuff like that, where I understand, these basic filters, how to shape a signal, and I can envision it in my head. Like I know what the synthesizer, like all of these block components and these things are doing. So it seems like I was like, regardless of how much I enjoy it, this is at least something that it's like I could tolerate and there is respect towards it. Um, I think sometimes in a career, like that's okay. Like there are people who are tax accountants, and I don't think anybody is like seven and they're thinking, wow, I really want to be a tax accountant. But, there are people who are very fulfilled in that because, they at least they find fulfillment in doing it. And that's kind of where I was originally. I think the point at which I found that I like genuinely enjoyed it was doing it in my off time was probably about like a year and a half ago was when I started being like I discovered like PCB design and started actually designing my electronics. And there was this rapid progression because I had this college degree behind me where I learned all of these concepts. So actually being able to build out these circuits was really quick and intuitive to me. And I just started doing it in my free time. So like there was a certain point where it just like clicked like, wow, wait, I have these skills. I can do this on my own. Um, but I was definitely chugging out for a little bit where I was just like, these classes are difficult, but I like math at least. So I was just getting through it.
Do you have any ideas of what college students should do, especially early on, to kind of explore their interests to see what they like?
um, I can only really give good advice, in my opinion, to people who are kind of in STEM. And that is like, if you were in a similar position to me, who is the easiest for me to give advice to, which is like, you liked math, you probably liked some level of science and stuff like that. Look at like the core classes that diverge out into other things, right? If you do extra math classes by accident, like you go Calc 1 through Calc 3 and you maybe do linear algebra, then you find out maybe I actually want to do chemistry and I didn't need to do Calc 3 or linear algebra. You're not going to be in that horrible of a position having done an extra math class or two. So I think those like fundamental classes really stem out to a lot of other stuff. And there's 100% nothing wrong with just experimenting. Like if you see something that's not on your degree track, and again, like financially, if you can afford it, for me, I was on a full ride scholarship, so I wasn't particularly worried about going any way. It's okay to go STEM out to other classes and see if you like them. And if you can't financially afford it, you can always show up for free. Like a lot of professors are very okay with the idea of you just asking, "Can I just show up to this class and audit it and just show up for free?" I've done that for many graduate level math and signal processing classes, and I've never been told no. And I did not pay for any of them. I just showed up to the class, did all the coursework, learned everything. And I imagine that's a great way to explore around. So if I was going to put it into those 2 points, like very quickly, it's like math classes are important for almost everything in STEM. You're not going to regret doing them. And then audit classes that you think would potentially help you long term, whether it is just figuring out if you want to do it or not.
So, what kind of projects were you doing on your own time with things like PCBs?
Um, Trying to think. So I've done quite a few different things over time. I think the easiest like first projects that you could do if you're in electrical engineering is just creating development boards. So a lot of people, surprisingly, even some people that I was seeing in my electrical engineering degree, wouldn't understand that when you like I have right here, um, this is an STM32 Nucleo board, and essentially the actual processing unit, the microcontroller, is this IC in the middle, right? You can design something around placing this into it and design the actual PCB around that and start programming, and just don't worry about building the programmer. You can use a different programmer, just find the bare minimum to get something working. And the second you flash that, like there's just like a magic behind it that like clearly you know what you're doing. um, that is definitely the first best step to do with PCB design is microcontroller. And then, past that, you can look for like Adafruit components. So like one of the things that I did later was I just built like a stepper driver unit off of an A498 IC, which is integrated circuit from Lego Microsystems that handles like all the main analog components of a stepper driver and just branch it out. There is if you look into the data sheet, it'll have like an example schematic, and you can follow that pretty closely with some basic design principles and branch out something that works.
So, I saw that you did an internship as an electrical engineering intern. What did you do there?
So I've had a few internships. I had one in an MEP firm. So that was at Dabari. So that's like a really small firm. It was literally just me and the boss. And essentially, like how I even got into that is I just had a friend in like one of my classes who was just like, I'm leaving this firm to go to something else. Do you want an internship? And I was like, it's like a sophomore. I was like, yeah, I guess I want an internship. Pretty much just got hired on the spot because I'd worked construction previously and knew enough about what was going on that it was easier than teaching someone else. Um, but essentially, that's just like the codes around like a building, designing engineering plans behind a building and getting it approved. So it was just a lot of basic like riser diagram stuff like that. I wasn't particularly interested in it long term, but it was fun for the time being to learn a lot about those things. And then I moved on to Texas Instruments, where I got an offer from them. They're a huge semiconductor company. If you're in engineering, like one of the best ways to move up and be noticed by high schools is probably getting like a large semiconductor internship like that. It's definitely something they look at. And there I was kind of responsible for more quality assurance and failure analysis. And I helped qualify some of the tools. So they were building a new fab north of their Dallas fab in Sherman, Texas. And essentially, they have semiconductor tools that have these old processes that they know will work for a given manufacturing. And when they update the tools, let's say it takes two wafers at a time as opposed to one, you would expect the chemical process to be pretty similar, but there's obviously some level of modification towards it. So I was kind of doing some of that, which maybe wasn't in my role as like a quality engineer, but also like as an intern, if you just go around and ask people for stuff to do, if you don't have enough, they'll most likely give it to you.
Oh, do you have any advice for people who do get internships in these big companies? I've talked to people before on the podcast who kind of said what you just said to like talk to as many people as possible, especially people who aren't on your team, just so you can learn about a bunch of different roles and explore. What do you think about that?
That's I would say that's good advice. It's good to have like a niche for sure, but it's not uncommon to get into one of these big companies and find out that they in fact did not plan super well around you arriving at the company, and there is not a lot allocated for you. I showed up in a time where the company was clearly very busy and did not have the resources to like allocate work to somebody else. Like my manager was essentially the guy who was managing the entirety of like the the new fab that was going on, right? Like that's what he was going to get promoted into that role. So he was like unbelievably busy. Um, that advice is very good. I was able to go out and talk to other people and kind of find something to do. Because ultimately, like at the end of the day, it's good to have the name on your resume, but you also want to have the skills. You don't particularly want to go to this company and spend 3 months there and not have learned how to do anything. So I would heavily agree with that advice. I think it's good.
Yeah. So I saw that you're also involved in some research at your university. What are you doing there?
So with research, I kind of came back from Texas Instruments and I realized I didn't want like kind of the typical engineering role. I wanted to do more like development and design and stuff like that. And ultimately, in those positions, you need to be somebody who can like stand up, have the idea, and stand behind it. Because ultimately, like the product launches or fails, like you're fully responsible for that. Um, so I started looking for stuff like that at my university. I found this lab called Dynamic Microsystems. Um, Basically, what we do there is we work on MEMS devices, which are if you have like a mechanical system, maybe you have like a cantilever or something like that, you can actually build that on a very, very small scale into silicon. So they have these weird structures that they built into silicon, like accelerometers or gyroscopes and things like that. And my lab kind of primarily focuses on experimental usage of these MEMS devices. So what I do right now actually is I produce like the test PCBs that we use for them because a lot of them require a very, very high drive voltage, which is this idea of if you have a square wave going up and down at very high voltages, producing that, maybe if you're at like, 20 volts, you can produce that in a signal generator. Once you start getting to like 80 to 100 volts on the square wave that you actually need, it becomes a little more complicated. Um, and I've helped design some of those test circuits that we've used. I've also done a lot of clean room fabrication and stuff like that because ultimately we actually fab a lot of our own resonators in the clean room at UCF. So it's those bunny suits that you may have seen in like ads for Intel and stuff like that. So there's a bit of like genuine just technical knowledge in using these semiconductor tools as well.
Oh, what made you decide to start doing research? And What do you think you've gained from it?
So yeah, it's definitely that thing that I was talking about before with I wanted to shift more towards like the design, right, after Texas Instruments. And so I started reaching out to a bunch of stuff, after that, just because I figured it did seem like R&D kind of, R&D is research and design ultimately, right? It kind of clicked in my head that if I want to do design, I kind of have to have some level of research background. And I would say like what I've gained from it so far, probably one of the most valuable things in terms of just like if it was just like a simple like quantified what it's done for my life is, I wasn't going into it with this intention, but it made me very, very close with the PI that wrote my rec letter for my grad school ultimately. And that's done pretty significant things for me ultimately. When I applied into Stanford, I don't think if I didn't have strong rec letters behind me, I would have gotten in. And he's like pretty well respected within MEMS research, and he stood behind me essentially in my application. I think that really helped me.
Yeah, so moving on to Stanford, when along your undergrad career did you decide that you wanted to go to grad school?
So I, it wasn't like an original thought because originally I wasn't even sure if I wanted to go to college, and I got like a full ride scholarship, so it seemed at that point kind of stupid not to. I was originally gonna go Navy and join like the nukes, but the goal of that was to pay for college, and then once college was paid for, I decided to go and go do that. Right. As I got more and more through it, I kind of felt as I started college, I wasn't like this, spectacular student who did anything crazy in high school. In all honesty, I think I may have been like below top 100 in my high school. In all honesty, in my graduating class, like I did good, but it wasn't like anything insane. I just did really good on SATs, and that got me, farther. And so when I was kind of looking at this, it's like it's become clearer and clearer that like the more school I'm doing, the more I'm learning, the more remarkable as a person it seems to like be making me, whether it's just like emotional, I feel like I've matured a lot through the college experience. I feel like I've met a lot of people. I like my entire community and friends and support I made essentially in college, not even directly through college, but I think a lot of things brought me to where I am now. And those things all kind of culminated into a decision where it's like it seems kind of obvious at this point that I should be going to grad school, especially when it's like the absolute, worst case. Like if I don't get in anything like spectacular, I'm going back to UCF to work under my PI who I have right now, who's like a spectacular boss. I love working under this guy and I learned so much and I genuinely love my work environment. So it was like, oh no, I get to go to grad school probably for free because the research is going to comp my tuition and keep working with these people I like. So it was kind of a no brainer at that point.
So once you decided that you wanted to go to grad school, what kind of things did you start doing or switch up to, I guess, improve your chances of getting into somewhere good?
Um, I don't think I switched anything. Ultimately, like all of the things that I was doing, I genuinely did because I liked. As it sounds, ultimately, I do think the admission reps can tell if
Wait,
you're
sorry,
just
it
taking a
just
bunch.
cut out for like 10 seconds. If you could go back just a little bit.
Oh no worries. I was gonna say, like, as corny as it sounds, ultimately, I don't think I switched anything. I was kind of doing exactly what I had been doing the whole time, which is just like I looked at college as this chance to like refresh and do the best I could with grades. So ultimately, I had like a near 4.0 by the end of it. It's not like you could just switch, your junior year and say, well, I want to go to grad school now. I'm going to start getting all A's. Ultimately, the fact that like it was there was because I was working from the absolute beginning. The fact that I had these internships was because I was working from the beginning. And the fact that I had these connections with faculty and staff was because I was doing things consistently the whole time. Um, and part of that was that experimentation. So like I graduated in my 5th year, and part of that was because I was moving around and trying to see what I like to do. And when I found what I wanted to do, it was very easy to work, 10 hours a day towards something that I really wanted. Um, and I think one of the things that culminated the most into me getting into Stanford was I actually met one of the faculty at Stanford in the bioengineering department. And he had this startup he was working on. And because I had this background in PCB design and these personal projects I could show off, it was actually pretty easy to convince him that, like, hey, I can contribute something meaningful to this project. So I was able to start working with him. And, looking back, you might look at it and be like, that's obvious. You met someone who works at the campus, that's very obviously going to get you into the school, right? But if I was approaching it with those intentions specifically, like I'm just trying to get into this, I'm trying to extract this from this person, it wouldn't work too well. The reason it works so well is because I actually cared about it. He could sense that I cared. I wanted to contribute to a project. And then, after I worked towards it for, a year or so, it was pretty easy for him to stand behind me and help me.
What advice would you give to someone coming into college who thinks they might be interested in grad school?
Um, I'm trying to think. I would say try your best to be well rounded because, you want to go to grad school because you want to and not because you're forced to. Because while it was a very great experience for me, I've definitely seen for some people it can be a way to almost just extract underpaid labor out of students, essentially. And you want to kind of make sure that it's something where it's like, I want to do this. Because if you don't want to actually be doing research for what you're doing, you're going to sit there. It's going to be the most miserable experience of all time. Everybody's going to tell you to get into research. I would give you the advice to wait, genuinely read some of the research papers. Wait till something sounds interesting because it probably won't sound interesting till a little bit later. Um, but the second it's something that it seems like you care about, you're going to have ease in pursuing it. So, it's perfectly okay to wait. I actually think that it's almost hilarious to assume that you could get into research in a lot of these fields in your freshman or sophomore year. You might be looking more towards junior. So trying to get into any type of professional internship, mostly at like smaller companies, right? Because you're going to have a much easier time bridging into a smaller company before you get into a larger one. Target that maybe freshman, sophomore year. And while you should pay attention to research, talk to all your professors, you're probably not going to know what you actually want to pursue until a little bit of time doing that. So it's not, no timeline is perfect for anyone, but ultimately understand again, like you're just not going to be able to do this unless you care about it. It's, you're being mostly working completely for free for the first segment of it until you've proven that you're worth, um, you've done enough for it that it's like it makes sense to pay you because these budgets are usually quite small, and especially with like funding cuts due to sillier political reasons, you there's even less opportunities in it now. So definitely make sure you're very, very passionate. You're okay with contributing it for free at this point.
So once you go to Stanford, do you have any specific things you're interested in trying out there? And do you know what you want to do once you finish up and graduate?
Um, Honestly, a lot of the things for me is just the fact that the what's the word for it? I'm trying to remember the word in English, but there's like a word for something's very close to it. A proximity. So like the proximity to San Francisco, right, is definitely like a selling point for me. Definitely want to take the Caltrain, do a bunch of stuff in San Francisco. I'm looking to join the San Francisco Chess Club. I've gotten very into chess over the past year. It's been like a very fun hobby. Within the school itself, there's a couple professors that I've been kind of looking at for research. One of the main ones is Professor Arbabian. So he works in kind of medical settings for integrated chip design. And so I really want to get into, you know, analog integrated chip design, actually learn how we make these microchips. I've done pretty well at the PCB level and I understand electronics, but ultimately with like CMOS analog design, I don't particularly feel like I have that much of a background in it yet. So hopefully, get significantly more into that. And I would kind of hope to long term after graduating. I haven't had that great of a time working as like a random employee in these big companies. I would much prefer to like start something new. And I think like integrated circuit design for medical applications is like a very niche interest that there's very few people that have the expertise to do it. And there's actually kind of a room for somebody to start something new. So that would be the ultimate goal is ultimately to try and start like my own company in some way. Um, but obviously goals change as you grow as a person. So I'll see if I still care about that in 2 years.
Wait, for the integrated circuits for medical stuff, what kind of
Yeah.
applications would there be, you think?
So one of the biggest things that I kind of see right now is there's this idea of like how do we power medical applications because they need to be quite small, and there's this strangeness in it. So essentially, like there's this idea of inductive coupling. So if you have an iPhone, you can even see like the little circle around for the wireless charging. How that works is you have two inductors and they couple, and it's almost like a transformer essentially. Like if you've seen Transformers in physics 2, you know, that's kind of how it's pushing power across. So in a lot of these medical devices, the first step that people have kind of thought for powering it is we're going to send this over radio frequency with inductive coupling. So they're sending radio frequency over the air and then getting it onto the device. That way you don't have to have this bulky battery on you, right? And then past that, there is significant research into like, okay, well now if it's going past human tissue, what do we do? And kind of some of the research that I'm seeing in our Bobian's papers is they're using piezo arrays. What a piezo device is it's just something that physically, like if you apply a voltage to it, you can get a mechanical vibration essentially due to the crystal lattice of the structure. Quartz is a really good example. If you've ever seen like a grill lighter, if candles in here, I might even have a grill lighter. But like when you click it, you hear that click. That's a piece of quartz that's getting struck physically, and then it creates a small voltage potential. So you can also do that in reverse and create a small voltage potential, and then create a mechanical vibration. So once we've gotten this RF signal, and then we couple it into electricity here, what they want to do to get it past human tissue is they're using this piezo array to create these mechanical vibrations with that voltage to create ultrasound, which is kind of what you see for like imaging babies and stuff like that, because it has a much better impedance matching to human tissue. So you can get more of the energy through. So hopefully I didn't like explain it super too technical so people can't understand, but essentially like the idea is like there's different methods for transferring like power over these different mediums. And in human tissue, ultrasound is a little bit easier. Outside of the human tissue, radio frequency seems to be kind of the answer. And the research is kind of in how do we do this in the best way possible, especially for if we have like an eye implant or potentially like neural implants, right? And I really want to learn essentially from like what is the best, which are UC Berkeley, Stanford clearly have the best in these two fields, at least in my opinion, of people applying it. And I hope to kind of learn from them more the technical aspects of like when we're doing this, how do we get it done? And hopefully, like, as technology improves, there will be like legitimate medical applications and moving this into, actual medical usage.
So for my last question, I wanted to ask if you have one piece of advice for someone who's still in high school or early in college wanting to follow a similar career path as you.
Um, I would say probably one of the hardest things that's going on right now that I do think you will never find from a lot of the older generations is there is a lack of appreciation from them for how much easier it was to concentrate on something for them, right? It This is on you at all times. This is quite annoying. It is a constant addiction and distraction, and it is very hard to learn the same amount and become like achieve the same amount with this on you. And it's a weird paradox because it's like things like ChatGPT may be the greatest learning tool that human beings have ever made. It is truly like if you want to learn, ChatGPT is so unbelievably good. But it's also what, people are refusing to acknowledge is like it's never been harder to actually push yourself through and do it. Um, it's like the best piece of advice I have is like I haven't figured out what it is myself because like I am probably close to as addicted to my phone as anyone else ultimately. And most of the reason that I'm successful is because I was lucky and I grew up a little bit past when ChatGPT was used. Because if I had to look back, I probably would have cheated on all my essays in high school if I had ChatGPT. So like the best piece of advice is try your best not to use it. Genuinely learn the stuff. At the end of the day, the reason they're asking you to write an essay isn't because the piece of paper at the end is worth anything. That's a piece of junk and they will throw it out. That's the point. You are supposed to research and learn how to reason and do all these things. And I constantly see these people justifying the use of like AI tools and these shortcuts. And it's like, these are fair. When you are in industry and the goal is now the essay to be done, that's okay. But when you're in school and the goal is for you to gain these reasoning skills, you were hurting yourself so badly to use it. And I know it's very hard not to when you see all of your friends around you using it. I've definitely experienced like, significant amounts of people around me cheating in a class and I'm the only one actually doing it. But it will pay off long term. Like it's really hard to communicate that to people because obviously like, the advice I'm giving, it's changed so much that even me, I'm only 23. I just turned 23. I'm pretty distanced from ultimately like what someone who's 15 is going through right now in high school. But I at least can like appreciate that. And as much as they probably don't want to listen to me, I promise that that's the truth. Like, do your best to learn the most you can. That's all you can control.
But yeah, thank you for joining me on the podcast today.
Mhm. Yeah, no, it was a pleasure. I appreciate you reaching out to different people and trying to like create at least like a environment where people can kind of learn from experts because at least for me, I'm the first engineer in my family. There wasn't particularly anyone for me to learn from. So like essentially like everything that I learned was like off of YouTube listening to other people. So creating more of that's definitely a really good impact.
But yeah, thank you.